This is section 4.1, part B, how to sample well, random sampling. A sample chosen by chance rules out both favoritism by the sampler and self-selection by the respondent. Random sampling, the use of chance to select a sample, is the central principle of statistical sampling. The simplest way to use chance to select a sample is to place names in a hat, the entire population, and draw out a handful of people, which would be the sample. This is the idea of simple random sampling. A simple random sample, or SRS, of size n individuals from a population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. In everyday life, some people use the word random to mean haphazard, as in that's so random. In statistics, random means due to chance. Don't say that a sample was chosen at random if a chance process wasn't used to select the individuals. An SRS not only gives each individual an equal chance to be chosen, but also gives every possible sample an equal chance to be chosen. There are other random sampling methods that give each individual, but not each sample, an equal chance. When you think of an SRS, picture drawing names from a hat to remind yourself an SRS doesn't favor any part of the population. That's why an SRS is a better method of choosing samples than convenience or voluntary response samples. Writing names on slips of paper does not work well for large populations. In practice, people use random number generators by computers or calculators to choose samples. If you don't have technology handy, you can use a table of random digits. A table of random digits is a long string of digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, with these properties. Each entry in the table is equally likely to be any of the 10 digits from 0 through 9. The entries are independent of each other. That is, knowledge of one part of the table gives no information about any other part. In your packet, Table D is a table of random digits. So how to choose a simple random sample using Table D? First, you need to label. Give each member of the population a numerical label of the same length. Read consecutive groups of digits of appropriate length from Table D. Your sample contains the individuals whose labels are found. Always use the shortest labels that will cover your population. For instance, you can label up to 100 individuals with 2 digits. We can say 01, 02, all the way up and then hit 99, and then the last one would be 00. As standard practice, we recommend that you begin with labeling 1 as either 01 if we need 2 digits or 001 if we're going to need 3. The school newspaper is planning an article on family-friendly places to stay over spring break at a nearby beach town. The editor intends to call 4 randomly chosen hotels to ask about their amenities for families with children. They have an alphabetized list of all 28 hotels in the town. Use Table D at line 130 to choose a simple random sample of 4 hotels for the editor to choose. So the first thing we would need to do is we would need to label each hotel with 2 digits. So the first hotel we would label as 01, the second one is 02, 03, and so on until we get to the last hotel of 28. The next thing we would need to do is look at line 130 on Table D. Now this one is going to look like this line right here, and we are going to break that into 2-digit increments. So 69 is our first number. We only go to 28, so we're not going to use that one. The next number is 05. That is a number between 01 and 28, so we can use that one. The next one is 16. Again, we can use that one. Then we have 48. That's not a number we can use. 17 is a number we can use. 87. Then we get another 17. If you get a repeat, you skip the repeat as well. Then we have number 40, 95, another 17, 84, 53, 40, 64, 89, 87, and then finally we get to 20. So our 4 numbers that we selected are 5, 16, 17, and 20. And then we can go back up here and see which ones those were. So 5 was Beach Castle, 16 was the Radisson, 17 was the Ramada, and 20 was Sea Club. So the 4 places that we would call would be Beach Castle, the Radisson, Ramada, and the Sea Club. Now there is a way to generate random numbers on your calculator instead of having to use Table D. To do this, you would press the Math button, and you would select PBR, and you would select option number 5, which is Random Integers. You would tell it you want to start with number 1, you want to go to number 28, and then you would press Enter, and it will give you a random digit between 1 and 28. You can continue just to hit Enter, and it will give you more values until you have 4 of them. The basic idea of sampling is straightforward. Take a simple random sample from the population to use your sample results to gain information about the population. In some cases, it is just not practical to choose a simple random sample. For starters, it would be difficult to obtain an accurate list of the population from which to draw the sample. It would also be very time-consuming to collect data from each individual that's randomly selected. Sometimes there are also statistical advantages to using more complex sampling methods. One of the most common alternatives to a simple random sample involves sampling an important group called a strata within a population separately. These separate subsamples are combined to form one stratified random sample. This method works best when the individuals within each stratum are similar to one another in a way that affects the variable being measured, but there are larger differences between the strata. So to select a stratified random sample, first classify the population into groups of similar individuals called strata. You could do this in the high school by putting the grade levels together, so all freshmen, all sophomores, all juniors, all seniors, each one of them would be their own strata. Then you're going to choose a separate simple random sample in each strata. And then you'll combine all those simple random samples to form your full sample. So of the freshmen, we would take a simple random sample. Of the sophomores, we would take a sample. Of the juniors, a sample. And the seniors, a sample. All those samples we would combine together to come up with our complete stratified random sample. Choose the strata based on facts known before the sample was taken. For example, in a study of sleep habits of school nights, the population of students in a large high school might be divided into freshmen, sophomores, juniors, and senior strata. If the individuals in each stratum are less varied than the population as a whole, a stratified random sample can produce better information about the population than a simple random sample of the same size. Both simple random samples and stratified random samples are hard to use when populations are large and spread out over a wide area. In this situation, we'd prefer a method that selects groups of individuals that are near one another. That's the idea of cluster sampling. To take a cluster sample, first, divide the population into smaller groups. Ideally, these clusters should mirror the characteristics of the population. Then choose a simple random sample of clusters. All individuals chosen clusters are identified in the sample. So to think of this, imagine a large high school that assigns its students to homerooms alphabetically by last name. The school administration is considering a new schedule and would like student input. Administrators decide to survey 200 randomly selected students. It would be hard to track down a simple random sample of all 200 students, so the administration opts for a cluster sample of homerooms. The principal takes a simple random sample of 8 homerooms and gives the survey to all 25 students in each of those homerooms. The student council wants to conduct a survey during the first 5 minutes of all school assembly in the auditorium about using the school library. They would like to announce the results of the survey at the end of the assembly. The student council president asked your statistics class to help carry out the survey. There are 800 students present at the assembly. A map of the auditorium is shown below. Note the students are seated by grade level, and the seats are numbered from 1 to 800. To describe how you would use each of the following sampling methods to select 80 students to complete the survey. So to do a simple random sample, you would need to choose 80 of the seats at random. One way to do this would be to put it into your calculator as a random integer from 1 to 800 and collect 80 different seat numbers, then give the survey to those students who are in those seats. If we want to do a stratified random sample, the students in the assembly are seated by grade level. Since students' library use might be similar within grade levels, but different across the grade levels themselves, we'll use the grade level seating areas as our strata. Within each grade seating area, we'll select 20 seats at random. So for the 9th graders, we can use a random integer because we know the 9th graders are from 601 to 800. And we can do a random integer on our calculator from 601 to 800 and just take the first 20 seats that are selected. And we're going to use the same concept for sophomores, juniors, and seniors. And then we'll give the survey to the students who are in those selected seats. If we want to do cluster sampling, with the way that the students are seated, each column of seats from the stage to the back of the auditorium contains students from all 4 grade levels. So if I take a look at like this column here, seats 1 to 200 would represent 12th graders. 761 and 781 would represent freshmen. So we can see that we're going to have multiple grade levels in each column. So we can have 20 different clusters, each with 40 seats in them. So if we break these into the 20 different clusters, we need to choose 2 clusters at random to get 80 students for the survey. So we would use a random integer 1 to 20 to select 2 different clusters. So after we make our clusters, you would label those clusters and we would select 2 clusters at random and sample everyone in that row or that column of seats. Most large-scale sample surveys use multi-stage samples that combine 2 or more sampling methods. Analyzing data from sampling methods more complex than a simple random sample takes us beyond basic statistics. But the simple random sample is the building block of more elaborate methods, and the principles of the analysis remain much the same for those of other methods. So the manager of a sports arena wants to learn more about the financial status of people who attend an NBA basketball game. He would like to give a survey to a representative sample of more than 20,000 fans in attendance. Ticket prices for the game vary a great deal, so seats near the court cost over $100 each, while seats in the top row of the arena cost about $25. The area is divided into 30 numbered sections from 101 to 130. Each section has rows of seats labeled with letters from A, nearest the court, to double Z, which is the top row of the arena. Explain why it might be difficult to give a survey to a simple random sample of 200 fans. So you would have to identify 200 different seats. Go to those seats in the arena, find the people who are sitting there, and then collect the information from those people. So this means going to 200 different locations throughout the arena, which would take time, and people are not always in their seats throughout the entire game. Which would be a better way to take a stratified random sample of fans? Using lettered rows or to use the numbered sections as strata? Now remember, strata, you want the people in the strata to be as similar as possible. Since the seats that are closer to the court are more expensive and the seats at the top are less expensive, you would want to do it by row. So we would want to create or select our strata by the letter of their seats, not the section of their seats, so that the people in those seats paid roughly the same amount of money for their tickets. Which would be a better way to take a cluster sample of fans? Using the lettered rows or a numbered section as the clusters. So when you're doing clusters, you want each cluster to be representative of the entire population. So you'd want to do this by the section number, because each section number have people who are down at the court and all the way at the top, so it would represent the entire population as a whole.